Okay, so welcome everyone to our webinar series, and today we're going to be talking about buoyancy. So this comes up from again a discussion which we were having over ethical diving practices, and it seemed to me that people were confusing uh, buoyancy with something else, but it seems to me also that people have not been thinking about their buoyancy as a key skill so much. So I thought I might as well just give a breakdown of what I understand by buoyancy and what it means to me. And maybe this will help people think about their buoyancy better. So yes, most of y'all have been part of this webinar series for a while, and you'll know who I am. And Scuba Evolution India has been in business, so to say, of helping people learn to dive properly since 2015. And we now are also teaching instructors to be able to teach people better and helping them as time progresses. So today we're going to cover it in these sections. Basically, we've already gone through some of the stuff, and most of you all know Archimedes and must have heard of Archimedes as the person who discovered, so to say, buoyancy, and who gave Archimedes Principle while he was taking a bath in a tub. And some of this may actually be true, but it's mostly a lot of hearsay. But the fact of the matter is that this is Archimedes Principle, and it's basically an explanation of how a body is buoyed up by a buoyant force which is created by the liquid or the fluid that it is placed in. So basically, I mean, quite a few of y'all are engineers or have a background in science here, a STEM background, so y'all will understand this, that the equation of FB buoyant force is basically just force, and force is to mass into acceleration. So therefore, if you look at the dimensions of this equation, x is just a multiplication cross. It's not an algebraic equation. And I'd request whoever's got their mic on to please turn it off for the time being, and then we'll switch it on once again. So the volume of the fluid displaced, of course, depends upon the type of body that is in the water. So whether it's a sphere, a ship, for example, which is not a sphere, a cube, or even a human body, which is a completely different shape, and therefore the volume is different. And especially when we are diving, we want to be neutrally buoyant at depth. So it's not you being buoyed upwards in terms of outside the water. You want to be neutrally buoyant at depth. So it's a slightly different way the body works, or the buoyant force works on the body, because it will work at different, the overall buoyant force will be spread apart on the human body, because it's not a point system. So this is generally what it looks like when you're on the surface and you're being buoyed up by the buoyancy, the force of buoyancy, which is pushing you upwards. Now, the important things here is also, as a diver, which you understand is Boyle's law, and it's not just for our lungs, it's also for the variable buoyancy devices on our system, which is our lungs, our BCD, and our neoprene wetsuit or dry suit for that matter. And then the other thing which we need to know is that the density of water changes. Seawater is generally 1020 to 1030 grams per liter, and freshwater is generally taken at 1000, or basically 1 gram 1000 grams per liter, or 1 kg per liter. And so these minor changes make a change in the buoyancy characteristics of the diver and of the dive as well. So your other important things are your scuba set, your wetsuit, your weight, your diver. We'll cover that all, and that's again the mass, volume, and density of the body. And here where things make a difference is whether depending upon what kind of body size you have, when we move into the various components of that affect buoyancy, you have a fixed amount, which is the diver, which is a fixed component. You're not going to change that underwater, I mean, more or less. Of course, if you do urinate, you lose certain amount of water, and therefore that's going to make a change in your overall buoyancy. But your cylinder, regulator, and fins are again a fixed amount of weight and mass, and your weights are again fixed. You're not going to change them underwater. Accessories include your computers, your lights, bolt snaps, cutting tools, cameras, anything that you are going to carry with you, your slates, but that does not change its weight or does not have it does not compress basically. And amongst the various variable components, you have your lungs, you have your wet and dry suits, which are basically a variable volume dry suit, and a neoprene wet suit which compresses as it goes, as it is affected by depth. Your BCD, which again is a buoyancy control device, so therefore it has a compensating device, so it has air cells and certain amount of compressibility and expansion properties. And then you have the mask airspace, which is very minimal but still makes a difference for us when we're thinking about it in in a really proper manner. So what I know for a fact is that also you have different types of cylinders. So you have aluminum cylinders and you have steel cylinders. So based upon the characteristics of a different cylinder, as the gas keeps getting used from your cylinder, the cylinder characteristics keeps changing its buoyancy. So in that sense, the cylinder is also variable, but here I've included it primarily as a fixed in the fixed characteristics, because the volume so much is not going to change. It's mostly the density. As the gas keeps going out, it's going to lose, you're going to use some of the gas, and therefore the weight changes, sorry, not the density. So keep that in mind as well. It's a semi-fixed semi-variable number. So for the diver, what is important also is the body composition. So some people are have more fatty tissue, and some people have more muscular tissue, more muscle, and some people are bone heavy. So it depends upon what kind of body percentage, body fat percentage, body structure you have. And again, your size makes a difference in terms of your lung capacity. The average human lung capacity, so to say, or the tidal volume, or the volume which you're using for each inhalation and exhalation, is about half a liter. But some people with bigger lungs, and especially males with bigger lungs, is about 0.7, and females with smaller lungs can be about 0.3 as well, and children is even lesser. So those of us who are actually helping children in the pool or in open water, trying to teach them, you might notice that their buoyancy is really bad, and you might say this is what's going on. But the fact of the matter is that you haven't catered for the fact that they have small lungs, and then the buoyancy changes are going to be different, and their body fat percentage is different, their body structure is different, so therefore the amount of weight that you put in will be different. The next thing comes up is experience, and I'm going to show you a video at the end of this presentation, which will give you an example of what experience as a diver and what training as a diver and how task loading can affect you or not affect you, and so on and so forth. So experience, training come hand in hand and go hand in hand, so to say, but it's a lot to do with what you want at the end. So how you're being task loaded, what your goals are, and whether you are even being goal oriented in terms of photography. If you're taking a picture and you're not thinking about your buoyancy, you're not thinking about your breathing, you're going to have a problem. So the types of buoyancy jackets again make a big difference. You have basically three types in the recreational system, which you have the adjustable back inflation, and you have jacket BCDs. Now most of us use the adjustable and the jacket BCDs in a recreational scenario. Some of the instructors have now started using back inflation and back backplate wings, primarily because it gives them a better control of their buoyancy, and they're obviously more comfortable in the water, and therefore can keep their heads up even without having air in the front portion of their BCD. The jacket BCD is also called a stabilizing BCD, so it will generally keep you with your face up on the surface, but Underwater, it creates an issue where it is pushing you up. The buoyant force is acting more from underneath as well, rather than just being on top. So a jacket BCD is good for the initial training or in a recreational dive store, for example. But as you get more and more comfortable with your diving and gain more experience, you would want to move to a back inflation or a back flotation wing, backplate wing example. So these are the various weight systems which you also have. When you come to a whole component system, you have a waist belt, which is a standard belt. Uh, Plus, you also have a waist belt with pockets on it. So that's why I've not put it as just weight belt. You have two separate types. And you have BCD integrated weights like the Scuba Pro Hydros or the Scuba Pro Blacks, not the T1, the what's it called? A Black Hawk, sorry. And then you have a backplate, which is a metal backplate, which could be metal, carbon fiber, or steel or aluminum or carbon fiber backplate, which is a plate which attaches to your BCD at the back, and then you clip on your tanks onto it. You have trim pockets like some of the Aqualung, and also the Hydros BCD comes with trim pockets on the back, which you can adjust weights for your buoyancy specifically, because you might be feet heavy, you might be feet light, you might be big lungs, so you want to put more on the shoulders to bring it to come down to a good trim. And you have ankle weights, especially people who have got floaty feet, and even using a heavy pair of fins like jet fins doesn't help. And of course, using heavier fins also means that your feet have to work more. So if you just put a slightly maybe half kilo on your ankles, it settles it down, rather than put 2 kilos on each foot. And then heavy fins means a lot more kicking. A lot more kicking means a lot more muscle power being used. A lot more muscle power being used is also a lot more gas being used. Then you have neck weights, which are generally used by free divers, but also used by some photographers and technical divers who want to maintain their body position without straining too much. Sometimes this can be compensated when you're wearing a mask with a light on it or a camera on it. And so the Paralens is a nice camera which fits on your mask, and basically things like that. Or you wear a helmet and your head is slightly now in a head down position. Then you have a vest, which is just like some of us wear it in the gym, a weight vest where you put weights in and you do pull-ups and stuff like that. So just like that, it's a vest that goes under your harness. But again, a lot of these systems you've got to think about in terms of safety as well, and figure out how you're going to use it whilst diving. Whilst buoyancy is one of the primary concerns, safety is the bigger concern. When you're on the surface or whatever, which is why you want to decide how comfortable you are in the water before getting a backplate wing. So the ways to improve would be proper weightings. The first thing when you talk about proper weighting is think about what wetsuit you're wearing or what dry suit you're wearing, because each wetsuit and dry suit has its own buoyancy characteristics. If it's a new wetsuit, generally you're going to have about, for a full 3 mm wetsuit, you're generally going to need about 2.5 kilos of weight to keep it neutrally buoyant at 1 meter. And obviously it's going to change as you go deeper. It's going to change. And why I'm saying 1 meter is because I've tested it out at a pool and kept it around 3.5 feet with 2.5 kilos of weight. Dry suits are easier because they are negatively buoyant generally. Some parts of it which have neoprene, like the booties, or maybe if you've got neoprene neck seal, will be slightly buoyant. But generally they are negatively buoyant, but the gas that you put in creates a large volume, and therefore you have a kind of it's like another BCD that you have to take care of. So a neoprene shorty, for example, will give you about 1.5 to 2 kilos, again, new neoprene shorty. Now the other important part is your overall weight. So weigh your regulators, weigh everything together, put them all together in a bag. Just if you are really being particular about your weighting, put all the gear that you wear, excepting yourself, put it into a bag and seal it up. That includes your wetsuit. Put it in a mesh bag. So your regulator, your BCD, your uh, knife, computer, whatever, lights, wetsuit, all put it in a bag, zip it up, and see what amount of weight is required to keep it buoyant. Now that's the buoyancy you need for your equipment. Now add to that, maybe depending upon your body size, do a full weight check for yourself. Just get into the water with a snorkel and exhale and see how much, if you can go down. If you can't go down, add a couple of weights and see what happens with just a snorkel. And when I say snorkel, I mean just a snorkel, mask snorkel, and a pair of swimming trunks, of course, swimming costume. Of course, we don't want you scaring all the other people away, but just get into the water with that and see how it goes. See how much weight you need. Generally, different sizes, again, different people, different sizes need different weights. So so when you add those two weights, that's the weight you need for yourself. Now, if you're using an aluminum cylinder, you generally would put about 1 kilo for the change in buoyancy. Now, some people will say half a kilo, but what I've seen is it's about 1 kilo, which keeps you more or less comfortable from a 200 bar to 70 bar and even 50 bar. And as you go, excuse me, as you go shallower, as you use more gas, the cylinder gets more buoyant. So from the change in buoyancy from 70 bar to 50 bar is huge. Up to 100 bar, you would probably not have any real change. But the minute you start going below 100 bar, you'll start seeing the change and you'll find a difference in the buoyancy characteristics. So that's how you would weight yourself. Once you've weighted yourself, also the next important thing is to understand that you always wear the appropriate size. And I say appropriate size, I'm not sure whether the spelling of appropriate is right, but when I say appropriate size of the BCD and suit, as an instructor or as a dive master, you need a little bit extra weight in terms of being able to carry a spare weight for your student in case they need to be weighted, in case you made the mistake of not calculating their weight correctly, and therefore they are underweighted, and you might want to give them an extra weight in the water. Also remember that in case you overweighted your student, again, your mistake, not the student's mistake, you overweighted the student, you might want to take that weight extra back and put it onto you. So you might need a BCD which is capable of handling that extra weight for you, for your diver, and also in case you have a failure on the surface where your diver has failed, your diver's BCD has failed, and you as a dive master or instructor will now have to provide alternate flotation, basically give them help on the surface whilst using only your BCD. So for somebody who's XS, you would probably wear a small or cater for that kind of size. And here again, be careful of what you're looking at in terms of a BCD, because in some BCDs the change in buoyancy characteristics is hardly 1 kg. So 1 liter of air is approximately 1 kg of buoyancy in your BCD. So if you have a small, which is a 19 liter BCD, your large may just be giving you 20 liters or something. So be careful about what that is. Some different BCD styles, especially the travel ones, have much smaller bladders and give you much smaller lift than what you would be expecting. And the size also depends upon the physical size. It's not just the bladder size. So these are things which you need to pay attention to and cater for when you are buying a BCD. A suit, of course, has to fit comfortably without squeezing you or without making being too tight or too loose, because if it's too loose, a wetsuit is not going to work. If it's too tight, it's not going to work. It's just that simple. So you need to buy the right suit. And in case you don't get the right suit, buy a thinner suit, slightly bigger, and wear another undergarment like a rash guard or a thin lycra suit inside to add to the what you call thermal protection. You get really good half mm suits, so you could wear 2 of them if you're getting cold because one of them under a slightly bigger wetsuit. Now, physical fitness, you might think I'm joking about physical fitness being an issue, but physical fitness makes a big difference in your breath control. I mean, they both, physical fitness and breathing control, go hand in hand. So if you're a smoker, if you've got bad cardiovascular fitness, you're going to be breathing hard the minute you start finning, the minute you start breathing hard, like what we were discussing about uh, your tidal volume being the way it is. You're going to have issues where you're going to be breathing out and breathing in too fast, and therefore not being able to control your buoyancy. Because anytime you inhale, you're making a change of buoyancy by about uh, easily half a liter, so half kg buoyancy, and going up. And the minute you start going up, Boyle's law starts affecting you, and the volume increases. The volume changes. You're going back by the equation of the buoyant force. As the volume changes, you're going to have a change in buoyancy, which is going to push you up. So increase in buoyancy, increase in volume go hand in hand. So pay attention to your physical fitness. The more efficient you are as a breather, the more efficient you are in the water, the more efficient your buoyancy is. Your breathing control, again, ideally you would try and do the Navy SEAL breathing style, which is 4 in, 4 out, and hold 4 both times. But as divers, we don't hold your breath. So what you do is you would breathe long and steady. So generally 7 seconds of breathing inside. So inhalation is 7 seconds, nice and slow, and then exhalation is about 12 seconds. So try and do that, try and practice that on land, try and get that into your natural way of breathing. And with time you can improve it. With time you can come to a situation where you understand that maybe 7 and 12 doesn't work for me, but maybe 5 and 7 works for me, or things like that. But just pay attention to your breath. Half of us don't, because we just think it's normal. So once you get that into control, once you get that into a conscious effort, which comes to the next part, which is situational awareness. Your situational awareness is very important. You're taking a picture and forgetting about your breathing doesn't make sense. You're looking at your buddy and asking them if they're okay while you hold your breath doesn't make sense. So whatever you do, whether you're checking your gas, taking a picture, doing an out of air situation, doing a skill, looking at something interesting, making notes for your choral awareness, or your picking up garbage, everything has to be in concert with each other. So none of your gear should be dangling, none of your equipment should be hanging around. Your BCD should be streamlined and tight to you. Your weight shouldn't be moving around. Again, that's another thing which, if I go back to the weight systems, where you put your weight also makes a big difference in terms of your diving capabilities and diving position. So proper weighting, if you have, like I said, bigger lungs, maybe put a additional weight on the back, on the trim, over your shoulders, and things like that. But the idea being, for situational awareness, is that you need to, again, pay attention to your breathing, pay attention to your surroundings, which will of course change and make a difference in your breathing. Also, if you are suddenly looking at something and not looking at your depth gauge or your breathing, you will realize that you started to go up or go down, and that's going to change your buoyancy, which again makes a big difference. And then of course you just need to practice. You need to spend time in the water, you need to do dives, you need to get your basics sorted out. And honestly, all of this is something that is covered in the open water diver manual. Maybe not so much in terms of uh, how to do a weight check in your of your gear, but all this, what I'm talking about, is covered in the open water manual and should be covered in an open water course, in terms of because we spend a lot of time with y'all in open water courses. So one of the easiest ways to do a weight check on the surface after you've kitted up, and because once you go to a new dive site, you can't obviously know what the salinity content is over there, unless you have somebody taking a reading every day, or you're checking the oceanographic website every day, which has a tidal gauge over there and tells you the salinity. So assuming that you have everything on and you get into the water, what most agencies say is that you should be floating at eye level with an empty BCD. Now, when you're floating at eye level with an empty BCD holding a regular breath, think about what else you might be doing. Your hands might be moving around, your feet might be moving around. So one of the first things you need to do is put your arms across your chest and cross your legs. So the minute you do that and you're holding a regular breath, now there's no bobbing happening, there's no movement happening, there's no subsidiary uh, what should I say, motion or force acting on your body, which will change your bones. And you want to be vertical here because uh, you're looking at you being able to sink after that feet first. So once that is done, now once you're holding your breath at a regular breath, now you just need to exhale. If you exhale slowly and you start going down, which means you're waiting for that particular system is okay. Now what you need to do is you need to add half a kilo or a kilo of weight for your gas that you will use, from a 200 bar to a 70 bar tank. And when I said 70 bar, it's because I use rule of thirds, which is a decent amount of time gas to use if you've got your breathing and buoyancy under control in any case. So once you've done that, once you put that weight in, now the next thing is to get slightly just below the boat or wherever you are, maybe 2 meters under the water, and get into a diving position, which, as you know is flat trim with your fins up and head to knees in one sorry, shoulders to knees in one plane, head slightly up, and feet and fins up. So once you're in that position, just try and stay there for maybe half a minute and see what's happening to your body, whether your feet up, head down, head up, feet down, that kind of thing. And then maybe add or move a little bit of weight around how you're carrying it, just to get the position right. Once that is done, you're good to dive. Most of us just get into the water and say, oh, we're getting into the water and we're going straight down. And then when you're somewhere into the first 2 minutes of your dive, you realize that, oh, there's something going wrong. One of my weights is shifted to this side, one of my weights is shifted to that side, I'm tilting this side, I'm that kind of thing. So to avoid that, just spend the first minute sorting out your buoyancy. You might miss out on the first 2 minutes of your first dive, but it's going to help you in the second dive, the third dive, the fourth dive, as many number of dives you're doing in that location for that period of time. And generally, salinity does not change that much unless you're in a estuarine place where there is fresh water coming in and going to change the buoyancy. So with that, I just have a video now to play for you all, and the volume of this is not really important. So this video is about me and my buddy exiting a cave blindfolded whilst sharing gas, and we are making an ascent from 30 meters to 12 meters through the chimney in the cave. And I just wanted to see our buoyancy and tell me that what you think. Right. So during that particular exercise, we were blindfolded. We were making navigation decisions. We were sharing gas, and we were making an ascent. And both of us were in dry suits with side mount harnesses and side mount BCDs. So we had to control buoyancy of two separate devices. We had to stay on the line. We had no visual reference of our computers or any of our gauges. We were using the line as a reference for exiting and for navigation. So that's possible. It's not impossible. And we did it for about, I think, close to around 400 meters all the way to the exit, which is this exit over here. And it's just a matter of practice, training, and situational awareness. Think about what you're doing. We've been I'm sure you couldn't even see us you know change our buoyancy for our BCD, dump some gas from the dry suit. It's just going on as you go on, because those are the key skill is buoyancy and your propulsion and trim, BTP as we call it. That once you get those three skills sorted out, everything else happens. So case in point is just an example of it's possible, and it's nice and easy. There's no hurry, there is no panic, there is no pushing each other or moving each other. We're just following what we're doing, what we've been training for, and just doing a protocol which is as simple as a mask removal replacement or a regulator remove and replace in an open water situation. Of course, it's taken time. It's about a few days of training and a few years of diving for me, but it's possible. So there's no end to what you can do uh, in terms of diving. So what's the next step? Gradually build up, reach technical level, uh, come into a place where you can maintain a 1 meter per minute rate of ascent, maybe have a zero buoyancy change or half, maybe a few inches buoyancy change as you're diving. That's what you want to do. And honestly, being able to maintain your buoyancy is all about thinking about it. And in the initial stages, once you think about it and set it up, the rest just happens. It's just what should I say, it's just instinct thereafter. With that, I've ended, and we can now have a discussion. And any questions?
Hi, can you hear me?
Hi, Swas. Yeah, go ahead.
Hi, yes. So yeah, one of the topics we discussed that day. So the key thing to take away from this would be that you're mindful of how you're breathing and what you're doing to control your buoyancy. I think that's one of the important things. And also,
It's about breath control, everything. You have to understand how it works, which is why I was
yeah,
discussing
true.
everything.
And also doing a 5 minute safety stop at a 3 minute safety stop at 5 meters does not constitute good buoyancy.
Yeah, I mean,
So
which is why I was
it's
just
very
showing
easy to do it.
what it is. That it's
Yeah,
a safety stop is a safety stop. You need to be able to do that safety stop. It's a demonstration of good buoyancy at that level of diving. A demonstration of good buoyancy in a cave is what I just showed you.
yeah, definitely.
So each level, and this is on open circuit. Imagine doing this in a rebreather, or dual rebreathers, switching out to bail out, multiple
So
gases.
just one question.
So just
When
goes
you
on to different things.
dive blindfold, how does it feel to the senses? Because you can't see where you're going.
Yeah, you use your ears for buoyancy understanding.
No. I understand about buoyancy, but just how does it feel to dive with the eyes blindfolded?
Uh, just normal for me, because when I started diving in '99, my first dive was in Kochi Channel, where there was no visibility. Uh, when I was training to be a Navy diver, so I've always been had zero visibility conditions as my first experience. So I really don't know. I mean, it's just normal. Uh,
Okay. So just one more question, which is not actually part of the topics that you showed today, but something we discussed about. Um, the BCD does help a lot in maintaining your buoyancy,
Say that again.
but the BCD,
Yes.
yeah, the BCD does help a lot in maintaining your buoyancy as well. But when you started diving, you said you didn't try a BCD. You did not have one.
Right.
So how was that?
So again, it was role
I,
specific, right? We were doing work underwater, so we didn't need a BCD for maintaining buoyancy underwater. We were tethered to a line, so we went down to a
okay.
short line. We held the short line and we did the work there. And
And
our
how did you
depth
get the
was
oxygen supply? Was it
uh,
from the surface?
it was both surface supply, and we had a cylinder, twin cylinder, which we were using.
Okay.
But the whole
Okay.
concept
Okay.
also was that our depth was being controlled by the surface. So the surface would know how deep we were,
Okay.
and they would tell
Okay.
us to go deeper or higher or whatever. Because again, you're in zero visibility conditions, you're working, so your situational awareness is only on your job. The situational
Definitely. Yeah.
for your safety, everything is on the surface. So you don't consider, you don't really think about it, excepting when you're coming up. And again, when you're coming up on the surface, they will tell you on the surface to slow down or to hasten up, because depending upon the speed.
Okay.
The only difference was when you came onto the surface, you had to float while skiing without having a BCD. So that was the only hard
Yeah.
part. But yeah.
Okay.
Any other questions?
Vishu,
Specific? Yeah.
in terms of buoyancy, when becoming a scientific diver or a tech diver, um, like, what do you think is like which type of buoyancy is more important, a positive or a neutral one, when we are going near the reef?
Perfect buoyancy.
So you mean like neutral one, like to keep on the same level when we are going near the reef?
Perfect buoyancy. You want to do work underwater as a scientific diver, you're looking at stuff, you're taking notes. If you have a change in buoyancy more than half a meter, you're not going to be able to see what you're looking at, what you're trying to research on. And if you do that, what's going to happen is you will not be able to see the subject that you're trying to research on, and with that, you're not going to be able to do research properly. So you have to have perfect buoyancy, positive, negative, whichever way. Your buoyancy has to be perfect. You cannot touch anything, and therefore that also has to be put into head. But again, there are certain research environments where you would be actually working with tools and things like that, which you cannot be in neutrally buoyancy. You'll have to actually be on the sand or on a platform where you're working with tools, heavy machine tools, and you can't have neutral buoyancy. So therefore you need perfect buoyancy at that. So you need to be buoyant based upon the situation.
Good. Thanks.
To give you an example about public safety diving, when you're trying to recover a body, you're trying to salvage a motor or something which is stuck in the water, you may or may not be able to get underneath it unless you completely deflate your BCD and are completely negatively buoyant and moving around. And sometimes when you have to handle stuff or tools and manipulate things, you cannot have neutral or negative or positive buoyancy, because you're not going to get that effort to be able to the physical force is not going to be transferred to the subject.
Cool. Thanks, Vishu.
Anything else? Any other questions? We've had a really short session right now, so I'm pretty happy with
Hi,
it.
sorry. I have a few questions.
Hi, Sid.
Hi, how are you doing?
Very well, thank you.
So, the like different kind of firstly, the dive position that you described in that when you said the knees are up, I've seen a lot of people who keep them at like 90 degrees to their thighs. You get what I mean, right? They're up and right. And I was just cross-checking because I was like, just to see what the neutral diving position is according to open water and all of that. but it doesn't specify this particular angle. It's like if horizontal is your flat line, then you're supposed to be like, let's say 5 degrees, 10 degrees off of that, like underneath, and your head's a little up, and your legs can be mildly bent, but it's not a big deal whether or not they're at that 90-degree angle. But I've seen a lot of people with this 90-degree thing. And could you explain why that's a better position than, let's say, your normal you're showing something on this? Yeah, that one, yeah. So why is that like a better position versus like just keeping your legs mildly bent or pretty much straight and just looking a little bit down?
So the first thing is that your fin position, in this position you can have a multiple multiple different propulsion systems. You can fin, do a modified flutter kick, you can do a frog kick, modified frog kick, back kick, helicopter turns. So the position itself allows you to move around a lot better, number one. Second, if you have this position, your hands are free in front and you can see whatever is there. You can manipulate tools, you can manipulate a camera, you can, it's right there in your vision. And you know that your entire body is in the same plane. So if you just tuck your head down in this position, because your whole body is in the same plane, you can see anything under your feet, behind you. So as let's say for example, I'm reading a dive and I've got a couple of fun divers behind me, or a group of students doing a fun dive with me at the end of their dive. I'm just showing them stuff, but I don't know what they're doing unless I turn around and corkscrew myself. Now if I just looked under my chin down and looked under my chest, I would see them completely at the back without having to do anything. So and again, when you're in a sensitive environment, if you can see it, you're not touching it. It's just that simple, because everything else is in the same plane, from your chin, like I said, from your neck and shoulders, all the way down to your knees, and your fins are up. So you're in that position. Everything else, so if you can see something below your face, your fins and everything is obviously above it, so nothing's going to touch, nothing's going to dangle or hit anything.
Okay.
So that's the concept of having this so what you call trim position. It's like basically like a free faller, like a skydiver in that position, but feet closer, not spread out.
Could you also elaborate a little on all of those finning techniques that you described? Because I'm only familiar with like frog kicks and the normal scissors.
We will probably do another webinar on propulsion. Good idea.
Okay.
Because
I
mean, it's a bit difficult to explain. I mean, I'll have to obviously take some videos of Facebook and stuff like that. But I can send you a link. I'll send you a link. It's much better rather than me take a whole, talk about it when we can't do a live. It's best to do a live. And what I do a fin workshop for all my tech courses for definitely.
Okay.
So
thanks.
Yeah.
What is the importance of lift capacity in a BC in general? I mean, it's not in the sense that's the maximum capacity you can lift, but do you take that into consideration or in your normal buoyancy?
Again, it depends upon what kind of system you're in. If you're using a backplate wing, then you would obviously have a donut or a horseshoe wing, which is it's shaped like a donut or shaped like a horseshoe, and that's where the air cell is. So your gas would be filled on that, around that donut or around the horseshoe. If you're using a jacket system like I showed you, it will be in the front. So your lift capacity would also mean different parts of your BCD has different amount of lift. So if for example your hose kinked, or your hose or your strap pressed down on your BCD, one part of your BCD would not get lift at all. So how does it affect your overall buoyancy in terms of buoyancy distribution and air cell distribution, and whether it's the shape of the cell actually. The lift, of course, depends upon, like you said, the maximum amount of lift it can take, which basically would mean, can you dive with a tank, with 2 tanks, with 3 tanks, with 4 tanks, with steels, with steels and a scooter, with a rebreather, steel, scooter, camera. So all, depends. Diverite also has a tank BCD. So for side mount tanks, especially when you're doing steels and you're doing no mount, so basically you remove the tank from your side, and you have to push it through a small restriction. A steel tank will straight away go down. It doesn't have any buoyancy characteristics. So you have a small BCD bladder which fits on the tank, which you can fill up with your LPI when you want to do that kind of a situation, to make it neutrally buoyant in the water, in a cave, when passing through a restriction that's small enough for you to have to take off your tanks. So it just depends upon what role you're looking at. But size would matter in terms of how much lift you need, more than anything else. How many tanks?
Thanks.
So I don't know who Cobra Commander is. I don't know his name, but Cobra Commander has a question. Does the fin buoyancy change with saltwater to freshwater? Yes, it will, because at the end, what should I say? Formula is the same, right? Buoyant force is equal to the density of the water into the volume into the acceleration due to gravity. So if you have that kind of a situation, you change the buoyancy of the water, the density of the water, the fin buoyancy is going to change. So, yep. Any more questions?
Vishu, I don't have a question, but question regarding that. But can I get the hoodie?
Pardon me?
The hoodie, your scuba evolution India hoodie. Where can I get that?
Where can you get that? You'll have to speak to Commander Warrior for it. We have them in Goa, and I don't know where, how we can send it across to you. Or maybe when you come down to the shop, we can probably you can buy one.
I'll probably come there on November, so I'll get it.
So we have them in the shop there. We have hoodies, we have t-shirts, we have mugs, I think, but I'm not sure whether how many mugs we have right now, but we have hoodies and t-shirts for sure. And caps, some caps, stickers.
I think I'm going to return home with an empty wallet.
Fridge
Probably with a
magnet.
negative wallet.
Spend more time with us. It's always good.
Yeah, then my bank balance will also go in negative.
We might give you a t-shirt or so free. Okay, any more questions? Any more before I stop the recording, and then we can, degenerate into our usual nonsense.
Oh, one last question.
Yes, it.
What is somebody else brought up the topic of scientific diving and all of that. But what is the ideal distance you should maintain from whatever that you're observing? Because I've seen people go down like almost 5 mm raising still not doing anything, and it's just really amazing. But then you don't have to be that low, in general. But then 3 or 4 meters over whatever it is, that gets far. So like, what is the ideal distancing you'd want to keep from the subject, whether you're a photographer, whether you're in scientific diving, maybe?
Again, it's different, right? If you, depending upon what kind of observation you're taking and what kind of work, if you're taking a macro shot, you would need to be really close to it. If you're taking a sample, you would actually need to be right with it, and maybe cut a sample or pick a sample and stuff like that. And a lot of people say yes, there have been people boring into coral and damaging it because of whatever reason. But if you're taking a scientific sample, you're taking scientific sample for study, for a better understanding of the substrate or the material. People take live samples as well, so you have to be close to it without damaging anything else. So that's how close you would have to be. As a recreational fun diver, I would say about half a meter is more than enough. Going anywhere closer
Okay. So buoyancy deals with vertical movement up and down, but how do you control um in like on Suzy when you're coming down from the bow and you come to the end of the ribs, there's one particular arch which is big enough which you can go under, which I was doing before. I was told not to do it, so I'm not doing it anymore. But the thing was that every time I went under it, my legs would end up scratching the side, not even the top, not the bottom, but the sides. So that is like, do you have any suggestions on how do you control movement from side to side versus
If it
horizontal, vertically?
if it is too wide, I mean, if it is not wide enough, you shouldn't go through it. I mean, if you're going to scrape through it, if your body size is big, too big, is if it's bigger than your body size is bigger than it, obviously you're going to scrape it. Apart from that, propulsion techniques, will probably have to do a modified kick in order to do it. So just that. Okay,
Thanks
so
again.
yeah, welcome. So some questions on chat. One is, do I recommend light or heavy fins? I don't recommend light or heavy fins. I recommend the right fins for you. And I have 2 pairs of fins right now, which I use based upon my type of diving that I'm doing and the type of equipment that I'm using. So for wetsuits, I use a different fin. For my dry suit, I use a different fin. I'm trying to work out a situation where I'm using the same fin for everything. But so far, I haven't been able to reach that situation. Sam Mitra says that he had some problem while cold water diving with a 7.5mm suit and becoming negatively buoyant. Any particular tips or advice? I would have to know a lot more about what equipment you were using. Were you using steel cylinders? Were you using what should I say? Twin set? Did you have a single set? And were you overweighted because of the 7mm, 7.5mm suit? Or I mean, if you can just unmute, I'm just going to unmute you so you can maybe talk to us and tell us more.
Yeah, so I was actually using a single set, and it was a steel tank, and I'm assuming I was probably overweight because it was maybe one of the few times that I have actually gone cold water diving. So I wasn't sure, whether it was the tank or just being overweight in general.
So possibly you didn't have the luxury of doing the first, like I said, spending the first 1 or 2 minutes once you get into the water in fine tuning your buoyancy to that particular rig. I mean, just that's the only explanation which I can think of straight away. Because irrespective of what rig you have, you should be able to weight yourself in a manner that you are neutrally buoyant at depth and be able to be positively buoyant on the surface with your BCD. So there shouldn't be a problem unless you've not had that time to actually spend about a minute on the water at about, like I said, 2 or 3 meters to just figure out what's going on. And of course, this happens. I think, were you at the sardine run during this time?
No, this was last year off the coast of Spain.
Okay. Because normally this happens during times when you have to get into the water quickly, and the dive charter is just pushing you into the water and saying go 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 kind of thing. And because they don't want you to miss out on the experience of seeing the sardine bait ball or a whale or something specific over there. So for that, I mean, the only other thing I would say is you could have spent a day before or a few hours before that actual dive in maybe the local harbor with that same equipment to get comfortable. Maybe it would have paid $50 more. Or
next time, I'll keep that in mind next time. Thanks.
That's the only thing I can say. That, weight yourself properly before doing anything.
Right. Thanks again.
Yeah. Varun says that he's observed due to cold water shock, diver doesn't exhale completely. So actually, what happens in cold water shock is you have a trachea, your what's it called? It's a pharyngeal spasm. So your trachea closes up. Any physician here?
Okay, I know zoology and yeah, what you said is right. It's trachea that freezes.
Is there a physician in the house? Is there a doctor in the house?
There are no medical doctors here.
Okay, so basically what happens is that you have a pharyngeal shock. Your pharynx closes up and your trachea closes up, and you are not able to get gas in and out. So which is also one of the reasons why people tend to can drown in cold water, which one of the reasons of cold water shock. So it's not just doesn't exhale. The thing is that they can't exhale or they can't inhale. So you have to, which is what you might call kissing the water. So you basically take your mask off and you just put your head in the water and or splash your water with cold water, so the mammalian dive reflex kicks in, rather than suddenly jumping into the water and getting cold. So that's one of the options available to you. Yeah, so wondering whether I prefer DIN or yoke. I always use DIN. I've been using DIN since 2014 now. Initially, I had yoke for my recreational set. And once I became a technical diver, once I became a side mount diver, I started using purely DIN. I have all of my personal regulators are all DIN. I have 3 sets of equipment for technical divers in the dive shop, which are all DIN. I only use DIN for my diving. Yeah. Okay, thank you very much for being here. I'm going to stop the recording now, and then we can have a general discussion about anything we want to talk about, because that's not going on YouTube. Thanks so much.